What I want to look at here is one of those questions where they're basically asking you the time between 2 points in an oscillating object. So we'll use the pendulum, and we've got one where we've got a, let's give it a, this time we'll give it a 12 centimeter amplitude, so A equals 0.12 meters, and we'll give it a period of 1.1 seconds. That gives me an omega of 5.7 radians per second. Now, if we want to know, for example, how long it spends between 3 centimeters on each side, okay, so that means as it comes down, when it gets to 3 centimeters, it then will spend a certain amount of time going from 3 to 0, from 0 to 3, then it is out of that zone, and it goes all the way back up to 12, back down to 3, back down to 0. So I want to know how long it spends within 3 centimeters of the equilibrium point. So on my reference circle, for this situation, I've got an amplitude or a radius of 12 centimeters, and this is the 0 point. So what I want to know is how long it spends in the 3 centimeter zone. But it's got 4 times when it's in the 3 centimeter zone, right? So the time it spends in the 3 centimeter zone is these bits. That's what we're asking. So what I can do is go, well, if I know what this angle is, then I can times it by 4, and I've got this angle, this angle, this angle, this angle. If I divide those angles, so 4 theta divided by 360 times the period, then I've got how long it spends, because the period is how long it takes to go all the way around. So the time it takes in these two zones is just that angle divided by 360 times t. So we again need to find that angle, and that angle is just 3 divided by 12, 1/4. It's an inverse sine, so let's do the inverse sine of 1/4. Inverse sine of 1/4 is 14.47, or 14.5 degrees, times 4 gives us 57.9, because I didn't do the rounding. Divide that by 360 and multiply it by our period, and we end up with 0.1769, so 1.177 or 0.18 seconds. And that's it. So they could ask you questions like that.